Hello everyone, myself Chaitra Borkar and I welcome you all to the 8th live session of the NPTEL course Basic Environmental Engineering and Pollution Abatement. Some general information about these live sessions that these live sessions will be held on every week on Saturday from 3 to 5 p.m. And these live sessions are recorded and the recordings will be made available to you through my YouTube channel. So let's start for the overview of the lectures 36 to 40 conducted in the 8th week. So lecture 36, the advanced secondary processes uh, were discussed, and these advanced secondary processes are usually conducted after the secondary processes, which involve the chemical action of the microbes on the contaminants present in the wastewater. So, advanced secondary processes involve the bioelectrochemical systems, such as either microbial fuel cells or microbial electrolytic cells. Firstly, microbial fuel cells were discussed, and these electrochemical systems basically have a microbial film on the electrode present. So, in microbial fuel cells, what happens is the wastewater is passed through this microbial fuel cell system, and the contaminants present in the wastewater are acted upon by the microbe film present on the electrode, and due to which the proton as well as an electron is generated, and this electron passes through the outer external electric circuit and goes to the cathode, and this proton passes through a semi-permeable membrane as shown here, and it goes to the other side, to the cathode side, and here clean water is generated as well as the electricity is generated. So these fuel cells are basically generating electricity as well as clean water. The electron transfer mechanism for these microbial fuel cells can be either through an exogenous mediator added externally, or through self-mediating process. The proton transfer mechanism for the microbial fuel cells through the semi-permeable membrane was also discussed. The parameters which affect the MFC's performances can be the type of electrode material that has been used, or the pH of the buffer and the electrolyte present in the microbial fuel cells, the operating conditions for the cathodic and the anodic side, the types and the composition of the substrate. That means the wastewater that which is the coming into the fuel cells, the type of the oxidant used, and the presence and the absence of the catalyst. Moreover, the voltage and current calculations for these microbial fuel cells were also discussed, and there the the cell potential was calculated, and it is basically the difference between the electric potentials of the cathode and the anode, including the effect of the losses. Next, the microbial electrolysis cell was discussed here. Basically, the generation of hydrogen is done by the microbial action on the wastewater, and this uses the electricity to generate the microbial action. So here, electricity is being used to initiate the reaction. Next, the tertiary treatment processes were discussed here. This comes after the secondary processes and the advanced secondary processes. In the tertiary treatment, firstly, the adsorptive filtration method was discussed. Now, adsorptive filtration makes use of the adsorption of the contaminants present in the wastewater, and adsorption can occur through either physisorption or chemisorption process. These adsorptive filtration can be either in batch or continuous mode, and the different parameters which can affect this adsorptive filtration is temperature, the concentration of the adsorbate and the adsorbent. So adsorbate is the material which is getting adsorbed onto the adsorbing surface, and the adsorbing surface is known as the adsorbent. The other factors which is contact time. So how much time you are taking, there is contact of the adsorbate and the adsorbent, and the pH of the solution. The performance evaluation of an adsorbent was also discussed, in which the different parameters such as specific uptake. So, how much of the adsorbate is getting adsorbed onto the adsorbent, given mass of the adsorbent, and then adsorption kinetics, how fast is the adsorption taking place, and how fast can you regenerate that spent adsorbent. So, specific uptake of an adsorbent can be studied through isothermal studies, and one case of adsorptive filtration for fixed bed adsorption was discussed. Here, we say that the influent is the liquid plus the adsorbate coming in, and the effluent is the liquid free of adsorbate. This can be either liquid or gas. So, but here we are talking about wastewater, so it will be basically liquid. So, the liquid then passes through the beds of adsorbent. So, ideally, what happens is this is the feed, and this is the bed of adsorbent here, and this is the effluent, and this is the stoichiometric front. So at this point, this is the used up bed, which is this shaded area is the used up bed, and while this the blank area is the bed which has not been utilized up till now. And up till this point, the the amount length of bed is that length which is in equilibrium with the inlet adsorbate coming in. So here also you can see that this is in equilibrium with the entering fluid, and this is the unused part. And but this is a straight wavefront which you see in which will be occurring in the ideal case. However, in real scenario, this is the length of the bed, and this is the concentration wavefront that we get, and these are not straight line. So at t is equal to t1, this can be the wavefront, concentration wavefront, and you see that most of the length of the bed is unused. However, at T2, there is some saturation of the bed occurring, and then the concentration wavefront goes down, and you see that after this LT, LF, this bed is still unused. So you can say that the area between these two dotted lines is the mass transfer zone. And for then you go till TB, and this is the unused bed. Then you go till TB, and the TB is the breakthrough point at which the leading edge of the mass transfer zone almost touches the length of the bed. So, breakthrough point, you can also say that it is the point when the adsorbate starts appearing into the effluent. So, this can you can say that this is the breakthrough point. And the breakthrough curve is shown by this plot. Next, in the tertiary treatment, membrane processes were discussed, and in that, membrane processes are basically the physical diffusion processes, and different types of membranes based on the division factor and driving forces were discussed. The division factor can be the size, or the driving forces can be the driving forces can be pressure difference or concentration difference. So different types of filtration are also there present, such as microfiltration, ultrafiltration, nanofiltration, and reverse osmosis. And the comparison based on the size separation was also taken up. So as you can see, reverse osmosis is used for the smallest particles possible, while microfiltration is for larger particles. And Next, the working principle of these membrane processes were discussed. In that, this separation is through the semi-permeable membrane, and the terms such as feed is the whatever your wastewater is coming in. Retentate is the retentate or concentrate is the part of the feed which is not allowed to flow through the semi-permeable membrane, and the permeate is the part of the feed which flows through the semi-permeable membrane. And the different types of membrane shapes and modules were discussed. Shapes can be of flat type, tubular type, hollow fiber, and monolithic type. While the modules, which is a complete set of the inlet arrangement and outlet arrangement, as well as the housing and the filters. So it can be a plate and frame type. It can be of spiral wound type, multi-tubular type, or hollow fiber type. So in next in the membrane process, the types of transport mechanism which are applied during the different types of membranes which are used. So membranes can be either macroporous, microporous, or dense type. So for the macropores, the transport mechanism can be bulk flow through the pores or diffusion through the pores. So bulk flow happens when there is a driving force is usually the pressure difference, and diffusion occurs when the pressure difference is not as much, but there is a concentration gradient. And restricted diffusion through pores includes the size exclusion and sieving, while the for the dense membranes, the solution diffusion is the mechanism which is followed. So solution diffusion is basically the permeates which pass through the membrane. They basically dissolve into the polymer matrix of these dense membranes. So usually these membranes are of polymeric type. So the polymeric matrix, the permeates dissolve into the dense polymeric matrix, and they diffuse through the membrane thickness and then dissolve from the downstream side. So for the bulk flow through cylindrical pores, if we assume that the pores are cylindrical, and the flow through them can be given by the Hagen-Poiseuille equation, and the formula for the flow through the cylindrical bulk flow through cylindrical pore is shown by this equation. And here we use the tortuosity, as we assume we as the cylindrical pore may not be straight. Next, in the tertiary treatment processes, the advanced oxidation processes were discussed. In that, firstly, the advanced oxidation processes are usually the which use generally the hydroxyl radicals for oxidation. And these hydroxyl radicals are mainly used because they are highly reactive, short-lived, and harmless, as well as easy to generate. So, the working principle for these advanced oxidation processes is such that firstly, the hydroxyl radicals are formed, and then the initial attack of these hydroxyl radical onto the contaminants, while followed by the subsequent attack to generate the simple molecules. So, this is the mechanism which can be shown here. The oxidants generate the hydroxyl radicals, and they attack onto the organic molecules to form intermediates, and then finally the simple molecules. So the different types of AOP techniques that were discussed were UV H2O2. So UV light is used to uh, for the homolysis of the peroxide molecules, which generates the OH radical, means the hydroxyl radical, or you can use the HOCl in place of peroxide chemical, and there you get the OH radical as well as the Cl radical. So in this case, you can also go for the disinfection as well as the oxidation. In the ozone-based process, ozone is used for the hydrolysis to get the OH radical, and in Fenton's oxidation process, there is the use of the ferrous and ferric ferrous ions to generate the OH radicals from the peroxide, and for the photocatalytic oxidation, we use UV light to generate electron holes in the transition metals which are used, and these electron holes are then necessary to generate the OH radicals. And the light driven processes are the processes in which the visible light can be used to generate the OH radicals. So now we discuss the sample questions for the assignment 8. So first question is, the cell voltage of microbial fuel cell could be written as, so different formulas are given here. What is the correct answer here? Can anybody give me the answer here? Okay, so the correct answer here will be the first option. So the cell voltage is calculated by the difference between the electrode potential of cathode and anode, and also you exclude the losses occurred due to the activation losses, the ohmic losses, the concentration losses, as well as the losses due to the pH difference. So the correct answer here will be the first option. Next question, identify the factor or factors which affect the adsorption process. So first is the temperature. Yes, temperature does affect the adsorption process. If you are at a lower temperature, maybe adsorption may not take place, or you get to some higher temperature, the adsorption take place. Or if the temperatures are too high, the desorption may also take place. So yes, temperature is a factor which affects the adsorption process. The concentration of the pollutants or the adsorbents. So pollutant is the adsorbate, and the adsorbents are the different types of adsorbents. So yes, it does affect the adsorption process, and the contact time also does affect. So yes, all of the above answers are correct here. Next question, dash is used to remove phosphorus particles from the water. So here, alum is the correct answer. Alum is used to remove the phosphorus particles. Next question, the pore size in microns of the membrane required for reverse osmosis. As I had already discussed this, that for reverse osmosis, usually very low pore size are there, and the correct answer here is the last option. Next, the formula that can express the hydraulic diameter. So here the correct answer is the third option, which is 4 into the volume available for flow upon the total pore surface area. Next question, the advanced oxidation processes are the treatment procedures that generally uses dash for the remediation of organic and sometimes inorganic contaminants in wastewater. So here the correct answer, as I had already discussed, is the hydroxyl radicals. Next question. This is the image given for the process, and you need to identify which process is this. So here you can see the photocatalyst is already written here, as well as you see the light wave UV rays are being irradiated on this photocatalyst to generate electron holes, which generate the OH radical ion. So this is, as I had discussed, this is the photocatalysis. Next question, out of the following condition, the condition for size exclusion effect is? So the correct answer here is the last option, as the molecule size, when it is greater than the pore size, it leads to the size exclusion. The next question is, find water flow rate in meter cube per meter square of day when it passes through a porous polyethylene membrane by a pressure differential at 70 degrees Celsius. The membrane has 25% porosity with 0.6 micrometer diameter pores and a tortuosity of 1.5. Pressures on either side of the membrane are 500 kilopascal and 125 kilopascal. Assume membrane is 2 microns thick and flow is fully developed laminar flow. So you need to find out the water flow rate. So as I had discussed, the flow rate for through the membrane can be given by the equation. So epsilon is the porosity, D is the pore diameter, and P naught and PL are the pressure on the either side. This is at the inlet and this is at the outlet. And mu is the viscosity of the fluid, and Lm is the length of the membrane or the thickness of the membrane, and tau is the tortuosity. So here we are given at 70 degrees Celsius, we know the viscosity of water is 0.00042 Pascal second. And you need to find out the water flow rate in meter cube meter square per day. So this you can convert into Pascal day as, so here you now can find out the water flow rate. So the porosity is given as 25%, so we take it as 0.25, and we are given zero point 0.6 micrometer diameter, so 0.6 into 10 to power 6 minus 6 square into 500 minus 125, also multiplied by 1000 because it is kilopascals, upon 32 into the viscosity, which is 0.00042 upon 24 into 3600 into the length, which is 2 microns, or the thickness, which is 2 microns, 2 into 10 to power minus 6, into the tortuosity, which is 1.5. So if you calculate, you get the answer as 72321.42857 meter cube per meter square day, as the Q is in meter cube per day and A is meter square. So you get the answer as 72321. So the correct answer is the second option. Next is for a 100 ml solution containing 20 milligram per liter fluoride is treated with adsorbent doses, that is 6 gram per liter. The percent removal of the fluoride was 70%. Calculate the specific uptake. So the specific uptake is the mass of the adsorbate which is adsorbed or removed upon the mass of the adsorbent used. So here, firstly, we are given the adsorbent dose as well as the concentration of the adsorbate present. So this is given in milligrams per liter. So in 1 liter, how many milligrams are present or how many grams are present? But the solution here is only of 100 ml. So we need to consider the volume of the solution as well. So for 100 ml, the amount of fluoride present is amount of fluoride which will be present will be, if 20 milligram are present in 1000 milliliters, okay, so how many will be present in, so how many will be present in 1 milliliter? So 20 by 1000. And how many will be present in 100 milliliter? So 20 by 1000 into 100. So here you write 20 into 100 by 1000. So you get it as 20 into zero point 0.1 or 2 milligram. Okay. Next is this is the amount of fluoride present in 100 ml solution, and you are told that 70% is the removal. So the fluoride removed, or you can say fluoride absorbed. It will be 2 into zero point 0.7, which is 1.4 milligram. So this is the amount of fluoride absorbed. And next you are given the adsorbent dose. So for 1 liter, you are given 6 grams. So how many will be for 100 ml? So the same logic from here it applies. So if for 6 gram are given for 1000 milliliters or 1 liter, so for 1 milliliter it will be 6 by 1000, and for 100 milliliter it will be 6 into 100 by 1000, which is 0.6 grams. Okay, so this is the adsorbent used. All right, so then we need to find out the specific uptake. So specific uptake will be the fluoride adsorbed and the adsorbent used. So we are given fluoride adsorbed as 1.4 milligram and given the adsorbent used as 0.6 gram. So 1.4 milligram upon 0.6 grams. So this comes out to be 2.33 milligram per gram. 2.33 milligram of fluoride per gram of the adsorbent. I write the answer here. So the correct answer is 2.33. So any questions up till this point? Anybody? So if there are no questions, I'll go ahead and end the session for today. Thank you, everyone.